So first of all, discussing what is conjugate. So if z is equals to a plus iota b is the standard form of complex number, then z conjugate is represented by z bar and it is equal to a complex number obtained after changing sign of imaginary part. So what is conjugate? Conjugate of a complex number is also a complex number which is obtained by changing the sign of imaginary part. For example, if I have z as 2 plus 3 iota, then what will be z conjugate? As it has imaginary part as 3, you have to change the sign of 3 only. So you will get 2 minus 3 iota. If z is minus 4 plus 6 iota, what will be z conjugate? You just have to change the sign of imaginary part, not the real part. You just have to look at the imaginary part. So the z conjugate will be minus 4 minus 6 iota. What if you have z as 3 minus 2 iota? Then z conjugate will be 3 plus 2 iota. What if z is a plus b? Then what will be z conjugate? As you can see that there is no term containing iota. So this is all the real part. We will write plus 0 iota with it, and then z conjugate will be written as a plus b minus 0 iota. Similarly, if it is given like this, that z is 3 iota, then first write this z into standard form, writing it as 0 plus 3 iota, and then calculating z conjugate, that is 0 minus 3 iota. Similarly, if we have z as 1 plus 2 iota, we take conjugate, we have 1 minus 2 iota. And if we take another conjugate, if we take conjugate once more, so this minus 2 iota turns out to be plus 2 iota. So this gives us a property that z double conjugate is z itself. इस प्रॉपर्टी में ये बताया गया है कि अगर मैं z का 2 बार कॉन्जुगेट कर दूंगा तो वापस z ही आ जाएगा. अगर एक बार कॉन्जुगेट कर दूंगा, एक और बार कर दूंगा तो z कॉन्जुगेट मिल जाएगा. सो z के ऊपर अगर मैं ऑड टाइम्स कॉन्जुगेट लगाऊंगा तो आंसर कॉन्जुगेट में आएगा. अगर इवन टाइम्स कॉन्जुगेट लगाऊंगा तो आंसर z में आएगा. सी इफ z is equals to a plus iota b is a complex number, then mod z, also known as modulus of z, is a real number, real positive number. It is always positive, so it is a real positive number obtained by applying formula mod z is equals to square root of real part of z whole square plus imaginary part of z whole square. So if z is a plus iota b, we know that real part of z is a that is the part without iota, and imaginary part of z is b, that is the part with iota, and then modulus z will be square root of a square plus b square. So let's look at some other examples. If z is 2 plus 3 iota, then what will be real part of z? 2. And imaginary part of z? 3. Then mod z or modulus of z will be equals to real part whole square plus imaginary part whole square. So we have 4 plus 9 under root 13 is mod z. Looking at other examples, suppose we have
Good morning, sir.
good morning. We are doing modulus of complex number. So if we have z as 3 minus 4 iota, then what will be real part of z? It will be 3, and imaginary part of z will be minus 4, and then what will be mod z? It is square root of real part whole square, which is 3 square, plus imaginary part whole square, which is minus 4 whole square. So we have 9 plus 16, which is square root of 25, hence the answer is 5. You must note that modulus is always positive. Modulus is never negative. And modulus is not a complex number. Modulus is a real number. We never have mixed terms like a plus iota b. We always have a real number whenever modulus is calculated. So what about modulus of z if z is 2 iota? So first of all, you will have to complete its standard form, that is a plus iota b. So first, writing it in standard form, we have 0 plus 2 iota. Then real part of z is 0 and imaginary part of z is 2. So modulus z will be equal to under root 0 square plus 2 square, that is square root of 4, which is 2. A very interesting property of modulus. See, if z is a plus iota b, what will be z conjugate? We will be having a minus iota. If we calculate mod z, it will be under root real part whole square plus imaginary part whole square, that is under root a square plus b square. And if we calculate modulus of conjugate z, then it will be under root of a square, that is real part whole square plus imaginary part whole square, that is minus b whole square. This gives us the same answer. So this is a very important and interesting property of modulus, that modulus of z is always equal to modulus of z conjugate. A multiplicative inverse of a complex number is written as a raised to power minus 1, and it means reciprocal of complex number. So it is also a complex number obtained by taking the reciprocal of given complex number. For example, if z is 2 plus 3 iota, then what will be z inverse? It will be 1 over, it is the reciprocal of 2 plus 3 iota. It is 1 over 2 plus 3 iota. Now we never leave iota in denominator. So what we have to do is rationalize. So in complex number, to write a number into a standard form, we never leave iota in denominator. In order to remove iota from denominator, we have to rationalize. So in numerator we have 2 minus 3 iota, and in denominator we have formula a plus b into a minus b, which is a square minus b square. So 2 square minus 3 iota whole square gives us 4 minus 9 iota square. Now what is iota square? Iota square is minus 1. So this gives us 2 minus 3 iota divided by 4 plus 9, because minus into minus becomes plus. So our answer comes out to be 2 minus 3 iota whole divided by 13. In order to write it into the standard form, we will separate them and write it as 2 by 13 and minus 3 iota by 13. So if z is 2 plus 3 iota, then z inverse will be 2 by 13 minus 3 iota by 13. In the same way, if I have a question like this, if z is given to us like this, for 1 minus iota upon 1 plus iota, then what is z inverse? So z inverse is the reciprocal of complex number. So if z is this, then z inverse will be the reciprocal of given complex number. So numerator becomes denominator and denominator becomes numerator. Now again we have iota in denominator, so we are compelled to do its rationalization to remove iota from denominator. So in numerator we have 1 plus iota whole square, and in denominator we have a minus b into a plus b, which is a square minus b square. Opening whole square, in numerator we have 1 square plus iota square plus 2 iota whole divided by 1 plus 1, because iota square is minus 1. So we have 1 minus 1 plus 2 iota in numerator and 2 in denominator. So we obtained 0 plus 2 iota whole divided by 2, which can be separated as 0 by 2 plus 2 by 2 iota, which is written as 0 plus 1 iota. So z is 1 minus iota over 1 plus iota, and z inverse is 0 plus 1 iota.